What's up, YouTubers? So for today's video, we're going to be talking about hard facing. Now, in specific, hard facing with stick. You can actually hard face with TIG as well as MIG. Less common with TIG for sure, because it's not really the great process for that. But anyways, hard facing with stick. And if you're not familiar with what hard facing is, essentially it comes down to running a weld bead where the weld that's deposited is super hard and wear resistant. There's two primary types. There's a bunch of different rods. There's some safety concerns with it, all sorts of stuff. I'll be jumping right in it, so let's get into it. So the first thing I'm going to talk about with these, and it goes with all hard facing rods and, well, to be honest, welding in general, but especially with these, is the safety concerns. Now, these rods in particular, which some of them can be forms of stainless steel, other ones are just alloys specifically designed for wear and may or may not be related to stainless. Anyways, they all have severe respiratory potential issues. And I bring that up with these in particular because of how severe they are. Like a lot of these have very high level of manganese and other things that you just don't want in your lungs. So my 100% recommendation with these is weld outside with them. Do not weld in a closed, confined space with these. Trust me on that. And wear a respirator, preferably, because you do not want the dust, the fume, anything from this in your lungs. These are really bad for you. So with that said, let's talk about the rods in general. So as I said in the intro, these are specifically designed for wear. So you run beads on, say, a plow blade edge or a bucket edge or any number of things, and this will wear a lot longer than the base metal steel. And the reason that these exist is, well, for one, to repair stuff that's wore, and two, to prevent excessive wear. Now, there's two primary types of these, and it can be pretty confusing, so I'm going to try and break it down as simple as possible. All right, so hard face rods can be a little bit confusing, and let's knock the dust off of it so you have a better understanding of what you're dealing with. So there's two primary types of rods with hard facing, and this is for you home hobbyists. There's unbelievable amounts of hard facing that exists for special purpose. We're only going to talk about stuff for like plow blades and any kind of for wear resistance. So the two types are, you have a buildup rod, and then you have what I call a cap rod or a single pass rod. So another way to look at it would be multi-pass rod, single pass rod. These here, which as the name implies, buildup rods. These rods can be run as bead on bead on bead, so like padding beads on plate, and they can be run multiple beads thick with these buildup rods. When you're dealing with a single pass rod, which these over here fall more into the single pass rods, they're kind of sort of like a hybrid, but I would say they're more of a single pass. You do not want to layer these multiple bead deep, and the reason is that the weld will fail, and I'll explain a little bit later why that is. But if you end up using single pass rods for a buildup job, your weld will fail. There's no doubt about it. So you have to understand and use a correct rod for that. So these would be great for building up if you have a plow blade edge that's wore down like, I don't know, 1/4 inch, 3/8 inch, or you got a gouge in it and you want to repair it. Using multiple passes with this guy is where it's at. Okay, it'll build it up and then it'll give you wear protection. The trade-off is that this rod in particular, the buildup rods, generally do not have anywhere near the wear resistance of a lot of the single pass only rods. So ultimately, these tend to only be maybe 1-2 times more wear resistant than the base steel, versus when you get in some of those single pass rods out there, they're so hard it's almost unbelievable and they'll wear forever. So it's kind of a trade-off. Do you need to build up something, use this. If you want to put, a single pass on an edge of a plow blade or something, these, and there's a lot of other ones that are single pass more so than these, would be your preferred method. Now let's get into talking about some of the reasons why there's issues with multi-pass with these. All right, so let's do a little quick book learning session. Right here I have depicted multiple passes on a base metal plate. And this is, we're assuming hard face rods here. When you weld a bead on plate, your bead is a mixture of both your base material and the alloy of your filler rod. When you're talking about hard facing, which produces a weld that's extremely wear resistant, which also typically means extremely brittle, that weld will be less brittle than the alloy the rod is to begin with and more brittle than the plate. So it's kind of a mixture of the two. When you're using build-up rods, they're alloyed to where you can do multiple pass wide and multiple pass tall, and the finished weld does not become overly brittle to the point that it's likely to suffer failure. And if you look here, so if this first bead is a mixture of, say, your mild steel plate and a hard face, it's going to have maybe, we'll just, again, this is just a rough idea, say 75% of the alloy of the rod. So it's significantly more wear resistant than the plate, but also significantly more brittle. Well, then if you go and then run another pass on that, you're alloying that rod's pass with not mild steel, but with these beads, which are much harder. And you can see where after a few passes deep, your finished weld that you deposited could be stupidly brittle. And there becomes a threshold where it's so brittle, loses so much ductility that when it's stressed, the weld just cracks. And even it's very common, even during just cooling, that when you do multi-pass with a single pass rod, that the weld will literally just crack off on its own just during cooling. So that's kind of the reason why you want to use a multi-pass capable build-up rod if you're doing build-up, is because for multiple passes deep, it will successfully weld and not become overly brittle. Again, like I said, the trade-off is that single pass welds, alloy for hard face, have way more wear resistant. It's just you cannot do multiple layers with it. Now, the question often comes up, well, can you put a single layer rod on top of a multi-layer buildup? And the answer is probably yes, but that's one of those things where you're better off looking at the manufacturer of the products that you're looking at to determine if that's a possibility. I can tell you that I have done that before and have had success, but again, it's every rod of these is different. I mean, there's 1,000 different brands of these and different alloys, and if you mix and match the wrong ones, failure will be the result. So it's best to get your rods from the same supplier. So like if Hobart, which I'm not a big fan of these because they're so expensive, but like KT Tools or Studi or any number of these that are out there, Crown Alloys, get a couple of them from the same brand. That way when you look up their nomenclature online, they'll tell you what you have to do in order to get the performance you want out of them. Okay, so let's talk about how to actually weld with these. All right, so I have a Hobart rod here in front of us, and this is hard overlay. It says these are not spec'd like as a 7018 or anything like that. Most of the rods that you're going to run into are just purpose labeled. So this is hard overlay. Those over there, the KTs say hard face buildup, so no spec. There may be a AWS specification for some of them, but I don't have any of those. So I got a piece of 1/4 inch thick steel here, and we're going to do a couple beads. But before we do that, I need to talk about some kind of interesting things about these rods. So the first thing that you want to concern yourself with is that these rods are not meant to be run hot. If you remember in that diagram I just showed where the weld that this deposits is both an alloy of this metal wire in here as well as a base material. Well, the more that you run this on the hot side, the more dilution of this and the base material happens, which causes two serious problems. One, is that the more dilution of this, the weaker and less hard the welding rod is, or the weld. So your wear resistance when you run this hot is limited severely. And two, you can induce embrittlement or cracking in your welded steel. Now this is 1/4 inch thick. If you watch some of my other stick welding videos, you've seen that a lot of welding rods can penetrate almost halfway into this plate, okay? So about 1/8 of an inch or so, possibly more. Well, if you run this rod hot and deposit that high alloy weld material halfway through this plate, and then this is exposed to extreme stress, like say something on an excavator or even a plow blade, the probability of brittle failure is very high. So in very simple terms, you want to run this like a bead of caulk on the plate. And I know it's the opposite of everything that we've learned as welders, where, oh, you got to have it wetted out properly, all that. No, literally run this on the cold side. Just lay a bead just like caulk on there. As long as the bead's stuck to the plate, you're good. I mean, if somehow the weld just falls off, then turn up the heat a little bit. I don't think you're going to run into that problem. But you do not want this to dilute into here. You just want it to stick to it and call it good. Which brings up another point I have, is that if you think you're going to be doing, you know, gorgeous looking welds with this stuff, good luck. It's not going to happen. Like, this produces probably the ugliest looking welds you're going to generally find. I mean, it runs similar to like a 70-24. I would say very liquidy puddle, but bead appearance is not a concern with this. You're using it for the wear resistance. As far as angle of your rod, it's going to be the same as what pretty much any other rod you're going to run is, so nothing really special there. Now, these rods in particular, and I didn't read the package on these, but they specify a preheat temperature. You must abide by that. These Hobarts say 200 degrees. So we need to get this plate to 200 to 230 degrees in the ballpark of that before we weld on it. The reason for that is two things, okay? One, when the plate's warm, it will likely have a little bit better ductility, which is a good thing because these welds at this deposit shrink a stupid amount and they put a tremendous amount of stress on the toes of the weld, okay? So having a little bit more ductile plate due to the temperature will lessen the chance of the weld cracking. The second reason for that is because you do not want this weld to cool fast. By having the plate preheated to 200 degrees, as you weld, it's going to take a lot longer to cool to room temperature, which is going to give the weld time for all that stress to relax enough to where it doesn't just crack right off the plate. What you're going to find too, and it's not even mentioned on these packages, but if you try and do a buildup of this, of a ton of passes, and then you quench it with water, I guarantee you it's going to crack. So never ever do that. Don't quench it with water. Just give it time. Preheat and give it time. Don't rush it. You know, and if you're welding this stuff on say a 3/4 inch thick excavator bucket or something, guess what? When they say 200 degree preheat, that means the whole way through the steel. You do not want to just get a surface temp at 200 where in 5 minutes the surface drops from 200 to like 70. Like, you have to heat soak the part in order for that to work. And the most common failure of these is you're going to finish welding and like, oh man, that looks good. And then all of a sudden you hear a ping. When you hear that ticking or pinging, that's the weld breaking off of your base material. The second you hear that, you have a failure on your hands, and you'll be able to look back at the toes of the welds and you'll find it cracked right off. So anyways, what I'm going to do, I'm going to go grab a torch, I'm going to preheat this plate, and we're going to run a single pass on it, and we're going to look at it. All right, so I have the plate preheated a little bit. Hopefully it's close to 200. On this thin a plate, it probably wouldn't be a huge issue if the preheat was under 200. When you're talking 3/8 plate or thicker, you'd be in major trouble. Now this is an 1/8 inch rod. I'm gonna run it at 110 amps, which may be on the hot side for this size plate. I'll have to find out. So I'm not gonna speed this footage up, but you can see the massive amount of real small spatter. It pretty much runs like a fireworks sparkler. It's kind of hard to describe, but the molten puddle looks like a 70-14, but the spatter is almost like a 60-10 or a sparkler. The puddle's really, I guess, a little bit hard to see, but it runs kind of like a normal rod, so nothing too unusual. So the actual bead itself runs, I guess the closest I can think is 70-14. So it runs very, very similar to 70-14, 70-24. Yeah, that plate's pretty cool. I'm gonna let this cool off a little bit, or pretty hot. I'm gonna let it cool off quite a bit, and then we'll be back. All right, so now that I can hold this, let's talk about what we have here. So as you can see, for an 1/8 inch rod, the welded deposited fairly narrow, definitely more narrow than what you would expect from like an 1/8 inch 70-18, closer to like a 332, and that's good. Like the 110 amps that I ran this 1/8 inch rod at is about the limit of what you'd really want to do on quarter. Like I previously mentioned, you can run into base metal dilution problems and everything else, so that's looking pretty good. Now, it is fairly common with these rods, especially this rod that I just ran has probably been in that package for 5 years now, but it is fairly common. There's a little evidence of porosity there. There's some right here, little bit there. It's somewhat common to have that with this particular Hobart rod, and I find with a lot of the hard face rods that just happens. Is that a weld defect? Yes. However, again, we got to look at what this is used for, which is its wear resistance, so that is of no concern. Which it goes without saying, and I didn't mention this before, never use these rods unless you need to get out of the middle of the mountains of Afghanistan or something. Never use them to weld two plates together. The weld that'll be deposited will be so brittle that under stress it's just going to likely crack. So never do that. Only use these for hard facing. And I'll bring it up to the camera so you can see a little bit better. Yeah, there's plenty of evidence of porosity, but again, for the sake of this, doesn't matter. Now to show you how much harder this is, I'm going to take this file, which is just, I don't know how hard this file is, but I'm going to chew, and I can just feel this file bite right into this mild steel, okay? Left a divot without even really trying. It chews that. Now watch this. Hear the sound that makes? I'm going to bring it up to my microphone. Listen, this is bare steel. You can hear how it gets quiet because it's chewing into the steel. Now listen to this hard face. It's hard as a coffin nail. It will not, this file will not bite into that. I mean, literally all it does is polish the surface to where it's shiny. So you can imagine like how fast in an abrasive environment that this mild steel would wear, and then this is going to last forever in comparison. So that is the benefit of it. Now I didn't mention this before, but I will now. It's very common, and I'll put pictures up now, you'll see of excavator buckets and all sorts of like earth moving equipment where they do X's and swirls and all sorts of patterns with this hard face stuff. And I know that seems like, why on earth would you do that? Well, the reason is that when you put patterns, in that pattern traps dirt and rocks, and it holds it there. And then when you're using that bucket or that implement in the ground, the dirt ends up wearing on the dirt. So they kind of do this. Well, Anything that's exposed to wear, because it's held captive, the dirt in here, this will take forever to wear. And the dirt wears on dirt, and that can extend the life, 4, 5, 6 times on that bucket over just having it smooth without the patterns. So the patterns are done for a specific reason. That's not just done for no reason at all. Not only does it help with the wear, but you don't really want to be putting like a million beads and layering this, generally speaking, especially the single pass rods, because of the previously mentioned brittleness problems. So spacing out in an X pattern is a great way to get the wear resistance that you need, the dirt trapping capability, without putting excessive heat or metal on it. There's a couple other things I'm going to mention too. So there are a couple extra uses for this besides what I've mentioned, which is wear resistance. There are hard face rods that have very high impact toughness. So wear is one thing, but like say you have a rock crusher, right? And it hammers big, alloy hammers into boulders in order to bust them into smaller boulders. Well, those types of, like the face of the hammer doesn't really need abrasion resistance as much as it needs impact toughness. So there are hard facing rods for that. There's also hard facing rods for corrosion resistance. Now, unless you're in an industry that deals with corrosive chemicals, you probably have never seen or been exposed to those kind of rods or fillers, but those do exist as well. This particular hard face would likely have very high corrosion resistance as well, and simply because this is an alloy of stainless and manganese, so it goes without saying that its corrosion resistance is obviously a lot higher than the mild steel. The last thing I'll mention, and then we'll go to the conclusion, you don't see it in this, but I have found that this rod, or these rods, hard face rods, put an unbelievable amount of stress on your material. As this cools, it's very common, and maybe it's because this is such a small weld, but it will banana peel whatever steel you're welding. I've seen, like, this is 1/4 inch. Had I run that KT rod that's 532 and ran a single pass, it probably would have pulled this and bananaed this 1/4 inch steel. So this is not something that you want to typically use on thin steel. The reason being is that it's just going to banana everything. Everything's going to be warped. So keep that in mind. Like, this stuff works best on thicker steel. Technically, you could, like on this chipping hammer here, see how wore this face is? You could use a stick rod such as this and then weld a bead on it, or even TIG welded it, ground it down, and then you have a little bit more wear resistant edge. So even though this is thinner than this, you could technically do that and it'd probably be all right. But again, if this warps, what does it matter? It doesn't. It's just something to be mindful of. Because if you run 20 passes of this and then all of a sudden what you're welding on looks, like a modern art, you're in trouble. So let's go and do the conclusion. All right, so what did we learn today? Well, we learned a lot about hard facing. What's more to say, right? I guess, it all depends on what you're using this stuff for as to whether or not this is the right tool for your job. It goes without saying that it pays to read the instructions on these, and it also pays to check the manufacturer's website. Like, there's pretty decent instructions on how to use this, but if you go to Hobart's website or KT Tools website, they actually have a lot more usable information for these than what's printed there, so always check that out. And I didn't really mention it earlier, but it's worth mentioning now. Us as home gamers, we don't really know what metal we're welding on. I mean, we don't have, a $50,000 analyzer that we can just, test the steel, so we have to take guesses, and sometimes we're wrong. Well, if you're welding on some implement of some sort, and it's built out of high-strength steel or ultra-high-strength steel, and you use this on that, you may suffer failure. So one of the things that I found as I've been doing welding and repairing for a long time is that you want to follow like a base set of rules, which is always prep your material, preheat it if the manufacturer suggests it, be very specific so you preheat it to their recommended temperatures, et cetera, et cetera. Follow, good common procedures, okay? Just attention to detail, I call it. If you have a failure after doing all of that, aka the weld cracks at the toe or the weld splits in the middle, pretty much at that point, you have to tell yourself something is wrong. I need to find out what that is. So do not just keep doing what you're doing and think it's going to work. Like, failure happens for a reason because something is wrong. So figure out what's wrong, solve it, and then go from there. Which these rods may not be compatible with some kind of steel you're trying to weld on. And like I had said earlier with the build-up versus single-pass rods, if you use a single-pass rod and try and build up something, good luck. It's going to fail on you. It'll probably crack off before you're even done. So again, failures just means something's wrong. Figure out what's wrong, solve it. That's simple. Hopefully you guys learned something. If you got any comments, questions, you know where to leave them. Until next time, thanks for sticking around.